That eruption at Mount St. Helens, that was quite a catastrophe. It wasn't a catastrophe like Noah's flood, but it was a terrible catastrophe. And I think we can use Mount St. Helens and the events there as an analogy to help us understand Noah's flood. Now you might think, what in the world does a modern volcanic eruption have to do with Noah's flood? But actually, as we've seen, much that went on at Noah's flood was volcanic and tectonic related. And as it turns out, much that went on at Mount St. Helens was water related, particularly as that glacier up on top of the mountain melted. And as that material came down, it picked up dirt and mud and trees and whatever and descended the mountain as mud flows. And as these mud flows then came down the mountain and distributed this material there at the base of the mountain, believe it or not, it deposited up to 600 feet thick of water deposited strata there at the base of the mountain. Well, how long does it take to deposit 600 feet of strata? Oh, millions and millions of years. Well, no, it took one afternoon. When we look at these layers up close, we see that they're layered just like Grand Canyon. And look at them really closely, you'll see that there's paper-thin little layers in there. And you know, when I went to graduate school in geology, I was taught that these little laminations like that, those are the result of yearly deposits, maybe a winter-summer couplet. And so a geologist, to study this region here, the way that they would answer the question, how long did it take for this deposit to accumulate, they would go in there and they would count those layers. And there are millions of these layers in there, all of them deposited rapidly, but they would conclude that those are yearly deposits. And so they would say, oh, this deposit took long periods of time to accumulate, when in reality, it accumulated rapidly. Later, another mud flow came down the mountain and breached a canyon through that recent deposit. And this canyon, the more we study it, boy, it looks like Grand Canyon. It has the same feature. It's a scale model of Grand Canyon. Canyons don't take a long time to form. Now these events, particularly the eruption and that gas cloud that came out as the mountain erupted, devastated about 150 square miles of virgin timber, of forest, and the mud flows then brought these timbers, these logs into lakes and into the streams draining the mountain. Many of them, as they waterlogged, they assumed vertical positions and then sunk to the bottom of the lake, where they were buried in growth position, but not in growth location. Now this, at Mount St. Helens there, that refuted one of the classic arguments for an old Earth. We find it up at Yellowstone Park up in Wyoming, where numbers of petrified tree stumps are found in a number of different layers, and the interpretation is that each one of these layers represents a successive forest that was buried by volcanic eruptions and petrified over time, and they would say that this whole series of deposits took many, many thousands of years to deposit, longer than the Bible will allow. Well, here at Mount St. Helens, those tree stumps are petrifying now, and they're in these volcanic layers. They look just like the ones up at Yellowstone Park. And so, from Mount St. Helens, we can see that the classic argument that the Bible is wrong is wrong. The Bible's right. And furthermore, these decaying and waterlogging tree materials, as they sink, they're forming a layer of organic material on the bottom of that lake, and it's a peat deposit. Now, peat, we know, as the precursor for coal. The idea is that peat, over millions and millions of years of heat and pressure, will turn into coal. Well, actually, it's not quite that way. That's a story they tell about the past, but it doesn't really work that way. Actually, in the laboratory now, we know of a number of different ways in which organic materials can be transformed into coal in a matter of hours or minutes even. It takes the right conditions. It doesn't take a lot of time. In fact, it takes heat. That's the main requirement. Well, here at Spirit Lake on the north shore of Mount St. Helens, where all of these logs are accumulating and the organic material at the bottom of the lake, that's a peat deposit. And this is the first step in the formation of coal. It doesn't take millions of years. Even in nature, we look like we're going to have coal here before very long if the conditions continue.